Today my topic is 7 crystal systems. We are going to discuss these systems. We have to discuss the crystallography. The materials or solids are classified into two categories. One is crystalline solids, another one is amorphous solids. In crystalline solids, the arrangement of atoms are in regular manner. The in case of amorphous solids, the arrangement of atoms are irregular. That means the distance between two the successive atoms will be same in crystalline solids, but the distance between any two successive atoms are not equals in amorphous solids. Generally, the examples of these crystalline solids are calcite, tourmaline. Already we discussed in polarization. Calcite, tourmaline, quartz, etc. But in case of best example is the amorphous solids is glass. That means when a when a glass is broken, it irregularly breaks. But in case of solids, the breakage will be in regular manner. So the types of systems are 7 here. These crystalline solids are classified into 7 categories. That means the classification of basic cells. Actually, this is a unit cell, which is the smallest geometric element. This is a unit cell. It is a crystal. This is origin. This is A. This is B. This is C. Opposite to the A represents alpha. Opposite to B represents beta. Opposite to C represents gamma. That means the parameters ABC represents the crystal edges and alpha, beta, gamma gives the angle between edges. Edges are planes. So the dimensions of this particular crystal or the shape of this particular crystal depends upon these 6 parameters. That means by varying this ABC and alpha, beta, gamma, we will be getting different shapes of crystals. So now we discuss about those types. The total types are 7 types. 7 crystals are there. This is the easiest method to remember these 7 crystal systems, that is CTO or HMT. CTO or HMT. This is the easy method to remember. This is 2, 3, 4, 5, 6, 7. Now expand these terms. One is cubic, second one is tetragonal, next one orthorhombic, next rhombohedral, next one hexagonal, monoclinic, next one is triclinic. Here total 7 types of crystals are there. Now write the parameters. The parameters here. The first one is A is equal to B is equal to C. You remember that like this. Then A is equal to B not equals to C. A not equals to B not equals to C. Again you repeat these terms. A is equal to B is equal to C. A is equal to B not equals to C. A not equals to B not equals to C. Again repeat this term here, that is A not equals to B not equals to C. That means here with respect to the crystal edges, the 7 parameters are written here. Now basing on the angles, first one is alpha is equal to beta is equal to gamma is equal to 90 degrees. Second one, alpha is equal to beta is equal to gamma is equal to 90 degrees. Third one, alpha is equal to beta is equal to gamma is equal to 90 degrees. The three terms are same. That means the angles are equal at 90 degrees. Next, rhombohedral. Alpha is equal to beta is equal to gamma but not equals to 90 degrees. Alpha, beta, gamma are equal but not equals to 90 degrees. Next one, hexagonal. Alpha is equal to beta is equal to 90 degrees but gamma is equal to 120 degrees. Next one, monoclinic. Alpha is equal to gamma is equal to 90 degrees but not equals to beta. Last one is alpha not equals to beta not equals to gamma. So these are the parameters. You can easily understand this thing. So CTOR HMT, then expand these terms, then write these parameters like this: 1 2 3. Again repeat 1 2 3, then repeat the last but one here. Then here alpha, beta, gamma terms, the first 3 terms are same. Next one is entirely different, and next term is different from this. These 3 terms are just different. Then the crystals are classified into 3 types. One is simple cubic, second one is body centered cubic, third one is face centered cubic. This is simple cubic, this is BCC and FCC. These are 3 types of crystals. Let me tell you how the simple cubic will be. All sides are equal. These are 8 edges. This cube is having 8 edges like this: 1 2 3 4 5 6 7 8, 6 faces: 1 2 3 4 and 1 2. There are total 6 faces. In case of simple cubic, the 8 edges, 8 crystal diagonals consists of 8 atoms. This is called simple cubic. In case of BCC, Case of BCC structure, BCC structure, this is a cubic. This structure also consists of 8 atoms at its diagonals and one more atom at its center of mass. Here total 8 atoms, but each diagonal, that means here this part, this part contains 1 by 8th part. That means 8 into 1 by 8 is equal to 1. That means the total effective number of atoms, sir. That means the total atoms in this unit cell is 1. Here one more atom at its center of mass. This is called BCC structure. The number of atoms in this structure is 1 by 8 into 8. 1 by 8 into 8 is common for all the structures, plus one more atom. That means 1 plus 1 is equal to 2 atoms. That means the atoms per this unit cell is 2 atoms. That means 8 pieces here and 1 complete atom here. Third one is, this is simple cubic. This is BCC. Another one is FCC. FCC also one type of cube. This is FCC. This is FCC. 8 diagonals, contains 8 atoms. Along with this, each face will be having one more atom. This is one atom and this is one atom. The total availability of atoms will be 1 by 8 into 8 plus 1 by 2 into 6. That means at 8 diagonals, there will be 1 by 8th part of atom and 6 faces, that will be half part, that is equal to 1 plus 3 is equal to 4 atoms. Here the density of this unit cell will be low when compared to these two, because the total structure will be having one atom only. Here the total structure will be having 2 atoms per unit cell. This is some denser than this material. This material having 4 atoms. This BCC will be double dense than this material. This FCC is double dense than BCC material. Here the availability of this simple cubic, BCC and FCC will be in cubic. The availability of types are simple cubic, BCC and FCC. In simple cubic shape, 3 types of crystal structures will be available. One is simple cubic, BCC and FCC. Another one is simple cubic, BCC in case of tetragonal. Another one orthorhombic, simple cubic, BCC. Another one is FCC. Last one is BAC. BAC is called base centered cubic. That means in base centered cubic means which is similar to body centered cubic. That means the 8 atoms will be common for base centered cubic, but at the base one atom will be available. That means these upper and lower surfaces, the 50% of atom will be available. 50%. That means half atom here, half atom here. That is called BAC, base centered cubic. Next one, rhombohedral. Only simple cubic is available. Next one, hexagonal. Hexagonal also available in simple cubic shape only. Monoclinic available in simple cubic and BAC, base centered cubic. Triclinic available in simple cubic. If we count these things 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The total types of crystals are 14. These types of crystals are called Bravais lattices. Bravais lattices. Okay, this is the concept. First of all, we have to know how to draw these types of crystals. Then we can implement these shapes into these types by placing atoms at diagonals and at the center of mass and at midpoint of the faces. We will be getting the Bravais lattices shapes. Here this is the cubic structure. The all sides will be equal. These are called A, because A is equal to B is equal to C. Then the angle will be at any instant, that will be at 90 degrees. This is first crystal, first type of crystal. This is second one, tetragonal. Tetragonal. A is equal to B, not equals to C. Then alpha is equal to beta is equal to gamma is equal to 90 degrees. This is B, this is A. ABs are equal, but C is different, either higher value than AB or lower value than AB. And this will be tetragonal A, B, C. The angle will be 90 degrees. Third one, orthorhombic. Orthorhombic. The terms are A not equals to B not equals to C, and alpha is equal to beta is equal to gamma is equal to 90 degrees. That is of course this is A, this is B, this will be C. It means it represents a three-dimensional rectangular. This is A, this is B, this is C. This is called orthorhombic. Next one is rhombohedral. The terms will be A is equal to B is equal to C, but alpha is equal to beta is equal to gamma, but not equals to 90. But these three are equal, but these three are not equals to 90. I mean, this should be like will be like this. The angles may be same, and so it will be like this. This is the angles are not equals to 90. The sides will be same. Next one is hexagonal. So this we have to draw like this. First of all, identify the points. This is the easy method to draw a hexagonal. Join these two. Join these two. This is the hexagonal. This is A, this is B, this will be C. Here the angles are 90 degrees. Here this is C, the angles are at 90 degrees, but this will be 120 degrees. This also like this. This is 120 degrees. This is hexagonal. This is somewhat tough when compared to other diagrams. So we practice it, and by practice only you can draw very well. Otherwise you can't draw. Sixth one is monoclinic. The parameters are A not equals to B not equals to C, but alpha is equal to gamma is equal to 90 degrees, but beta not equals to 90 degrees. Then the three terms are not equals. The angle will be somewhat different. Beta, this is A, this is B, this is C. Like this, the shape will be like this. Next, seventh one is triclinic. The terms are A not equals to B not equals to C, and alpha not equals to beta not equals to gamma. The three angles also not equals. Then draw like this, an irregular shape. This can draw like anything. A, B, C. The sides are not equal, and angles also not equal. Each of planes having different angles. You can draw like anything. Here the examples of this terms are, in case of cubic. In case of cubic, the examples are aluminium, copper, NaCl, CaF2, NaSO2. These elements are examples for cubic. For tetragonal SnO2, TiO2, NiSO4 elements are examples for tetragonal. For third one, orthorhombic, KNO3, K2SO4 are the examples for this structure. Rhombohedral, SB, Bi, bismuth, calcite. These are the examples for rhombohedral. For hexagonal, Mg, Cd, AgI and quartz. These are the best examples for hexagonal. For monoclinic, CaSO4, 2H2O, MgSO4 are the examples for monoclinic. Finally, triclinic. This is somewhat complicated. K2Cr2O7, CuSO4 are the best examples for triclinic shape. These are the elements which are examples for this crystals. In next class, we will discuss about the packing fractions of these types of crystals. In case of simple cubic, BCC and FCC, the packing fractions will be the packing densities, packing fraction, or packing factor. Thank you. This is the lesson what I told you today. This is types of crystals. In case of crystalline solids, the basic structure of a crystal will be like this. This is called unit cell. The repetition of these unit cells gives the actual shape of the body. These unit cells, basing on these three parameters, A, B, C and alpha, beta, gamma. By changing these parameters, you will be getting different shapes of bodies, unit cells. The first one is, this is the types of 7 crystals, CTO or HMT. Expand these terms and remember these parameters. These are called Bravais lattices. This also you have to remember. Then the overall types of crystals, SC, BCC, FCC and BAC also there. Then these three are best examples for. These are the 3 types of these crystals: simple cubic, BCC and FCC. The next one is the diagrams drawn basing on these parameters. You have to draw. That means if you remember these terms, you can draw the diagrams easily. This is simple cubic, tetragonal, orthorhombic, rhombohedral, hexagonal with examples: hexagonal, monoclinic, the final is triclinic. So this is the lesson session today. Next session I will discuss the next topics. Thank you.